రిపేర్ చేసేటోళ్ళని ముందు చెప్పండి. రిపేర్ చేసేటోళ్ళని చెప్పండి అంటారా? Good morning, Nana. So, continuation of the class today, circular permutations and combinations, continuation. So, circular permutations. Now, linear permutations over. First, exercise 1, exercise 2, exercise 3. So, now this is circular permutations. So, what is meant by circular permutations? You have to take. So, that is meaning that the objects are arranged in the form of a circle. Then it is called circular permutations. So the objects always in the form of a circular permutations. It is in the linear form. It is make a row wise. Then it is linear permutation. Now it is circular permutation means the objects are arranged in the form of a circle or circle. Then it is a circular permutation. So how many permutations of indissimilar things can be done in at a time is, that is number of circular permutations always n minus 1 factorial, and second formula, that is already if it is in linear, it is a n factorial or in the row, where the number of permutations of circular n dissimilar things taken all at a time, that is n minus 1 factorial, and that is in the form of a hanging type, like that is garland of flowers and chain of beads, etc. All these of n things is given by half into n minus 1 factorial. So next fourth formula is there are n persons in around a circle, then the number of selecting 2 persons. This is in the form of a circle, person 1, person 2, person 3, like this up to pn. So consecutive means take a adjacent persons, that is there are n persons around a circle, the number of selecting adjacent persons, that is 2 consecutive persons is n ways, and another is n ways, and 4 of consecutive persons also take it as total number of, suppose it in the form of a 3 persons are there, suppose. So that is, let us take a 2 persons means one way, and this is the second way, and this is the third way. 3 persons taken, we got number of ways is 3 ways for consecutive persons. For 4 persons are there, suppose it is also 4 ways. That is similarly we can get as n minus 1 consecutive places means n ways. So that is the formula for there are n persons around the circle, then the number of selecting 2 persons is always n ways. So that is the form of a formula. Then go to the next one. There are n persons around a circle. For the next person to sit, there is on n places. Circular means, suppose sitting in the circle means 1, 2, 3, 4 are there. This is one way, this is one way, this is also one way, this is the third way, this is fourth way. If it is the 4 persons are there, next person to sit the another place is, there exist how many 4 members are there, you can get 4 places. Suppose 5 places are 5 members are there, you can sit in the arranged in a circle means the next person to sit there in the in how many places means 5 persons. Like that n persons around a circle can be arranged in n places only. This is the formulas for circular permutations. Then in this, on the basis of this one, we can go to the next exercise 5.4, very short answer type questions. Then the first question is, find the number of ways of arranging 7 persons around a circle. So 7 persons can be arranged in circle. So total number of ways are 7. So the formula is, the number of ways of arranging n persons around a circle is n minus 1 factorial. So here the number of persons are given that 7 persons. Therefore, the number of ways of arranging 7 persons around a circle is 7 n minus 1 factorial, that is substitute n equal to 7, then you get 6 factorial, that is 720 ways. 7 persons can be arranged in a circular means n minus 1 factorial. So that is 6 factorial ways we can get the value. Next, go to the second question. Find the number of ways of arranging 5 boys and 5 girls around a circle. So here total number of persons are 5 boys plus 5 girls. So total number of persons becomes to 10 persons. 10 persons in the circular means n minus 1 factorial formula. Then you get 9 factorial, that is the number of ways of arranging 5 boys and 5 girls in a circle is, around a circle is 9 factorial ways. This is the question number 2. Then go to the third one. Find the number of chains that can be prepared using 7 different colored beads. So like hanging tape, always you can get the anti-clockwise and clockwise are same. Then you get the total arrangements into double time. Then it is why we can get to half into n minus 1 factorial ways. So that is the formula for hanging tape, that is chains or beads, all those. The number of circular permutation like chain of beads etc. of n things is given by half into n minus 1 factorial. Here number of different colored beads are given, then substitute where n equal to 7, that is half into 7 minus 1, half into n minus 1 factorial. So that is here n equal to 7 different colors, that is 7 into 6 factorial. Don't cut it to 2 3s. This is a 6 factorial. Factorial means product of the first n natural numbers. So write all those 6 into 5 into 4 into 3 into 2 into 1. Then you get the value here 360. 720 by this total value 720. 720 means 720 by 2 nothing but 360. That is the number of ways of chains that can be prepared using 7 different colored beads, that is half into n minus 1 factorial. So substitute where n equal to 7. So that is half into 6 5. Don't strike off the 2 3's. Factorial is there. So you write as 6 factorial always. 6 factorial, how many, which number has come? So product of the first n natural number, that is. So don't write 3 factorial. Half into 6 factorial, that is half into 720. Then you get 360 ways. Like hanging type, like chain of beads and garland of flowers, all those have the formula of the number of circular permutations are half into n minus 1 factorial. If it is around a circular means the formula is n minus 1 factorial. On the basis only 2 formulas for this exercise. Next, fourth question. Find the number of ways of arranging 8 persons around a circular table if 2 persons wish to sit together. Wish to sit together. Always sit together means always from linear permutation we get always take it as a sit together, come together means always take it as a one unit, as 1 unit. So here how many are there? Persons are, so 8 persons around a circle, 8 persons to sit, 8 persons, 4, 5, 6. So that is 2 particular persons wish to sit, always sit together. If any place, any arrangement, you can always, these 2 persons will to sit to wish wish to sit together only. So here occupy the place, then you also the two persons sit together here only, and take this place also. You can arrange this two person wish to sit together. So always treat the two particular persons as one unit. Why? Because wish to sit together. So always make a bundle. The permutations of n come together means always you take as a unit method. You treat as a one unit. If it is no two come together means always you take the value for gap method. So that is why wish to sit together means treat the two particular persons as one unit. So total 8% becomes in these 2% is one group means 6% and 2% means one unit. Then total things are 7 things will get. These 7 things can be arranged in a circular way. So that is 7 things can be done in 7 minus 1 factorial, that is 6 factorial ways. Now the one unit has taken as two particular persons. Two particular persons make a bundle. So two particular persons can be done in 2 factorial ways. Therefore number of circular permutations are 6 factorial into 2 factorial ways. That is 720 into 6 factorial is 720, 2 factorial is 2, that is 1440 ways. So always sit together means make a bundle or make a unit. So totally here 8 persons are there. So that is why two particular persons as one unit. Then we have 6 persons plus two particular persons as one unit becomes to 7 things. The 7 persons can be arranged in a circular way. Circular means the formula is n minus 1 factorial, that is 7 minus 1 factorial, that is 6 factorial ways. Now they make a bundle, the persons are two member of persons are there. They can be among in themselves can be done in 2 factorial ways. So total arrangements of circular way is 6 factorial into 2 factorial, that is 1440 ways. This is the question number 4. Then go to the question number 5. Find the number of ways of arranging the chief minister and 10 cabinet at a circular table so that the chief minister always sits in a particular seat. So there is a way to chief minister chief minister can sit in any particular seat. So this is only the chief minister and the remaining 10% cabinet ministers are there. The chief minister can be occupied the place in only the one way. Chief minister means always occupy the place particular seat. In how many ways only? The particular seat means only one way. Then how many other cabinet ministers are there? 10 cabinet ministers. 10 cabinet ministers can be arranged is 10 factorial ways. If it is first one, arrangement is over. Why? Because chief minister in a occupied a particular seat means anyway he can sit. That is only one way he has to choose. Then the remaining 10 cabinet ministers can sit in, that is in ways of make it to linear permutation. The first option is over. To sit a particular seat means the first option is over. Then you get the 10 places. Then in the 10 places that the 10 cabinet minister can occupied by 10 factorial ways. So that is total factorial ways is 10 factorial into 1, that is 10 factorial ways. Or else you can total number of persons here you can, or else you can got another idea. Number of persons becomes to 11. 11 persons can sit in a circular way like this. 11 persons can be done in 11 minus 1 factorial, that is 10 factorial ways. This also you can get an idea. This is the first way or second, this is way, anyway you can get the same answer only. So total number of persons are 11. The first chief minister can sit in any particular seat means there is only one choice to sit there. And then they have the 10 members to sit the cabinet ministers, only 10 seats are there. So it can be done in 10 members. So becomes to linear permutations, then it is a 10 factorial ways. So that is 10 factorial into 1, that is 10 factorial total answers. And or else total here number of persons are 11, they can be arranged in a particular around the circle is 11 minus 1 factorial, that is 10 factorial ways. Both methods you can get the idea. Next go to the sixth question. Find the number of ways of arranging 7 guests and a host around a circle if two particular guests wish to sit on either side of the host. So find the number of ways of arranging 7 guests and a host around a circle if two particular guests wish to sit on either side of the host. So that is two particular person guests wish to sit together means either side. This means treat as a one bundle. Same method just now. So number of number of guest people are here 7 members. So the two particular wish to sit together. That is meaning that two particular guests along with the host as one unit. Why? Because they wish to sit together. A particular guest has to sit together either side of the host. Either host is there. This is the host. So the either side of the host means number of particular persons are 7 are there. So these particular persons with along with the host has to sit. Wish to sit to them means this has to take a one unit. So then 1 unit means total this person becomes 2. Then we have 5 guests and 1 unit of 2 particular guests along the host. So that is why they can be arranged in a circle is 6 totally 6. 5 guests plus 1 unit means totally 6 person. They can be arranged in a 5 factorial ways. Now the 2 particular guests can be arranged either side of the host is either sit in this side or this side. That is we get to 2 factorial. So therefore total number of ways of arrangements are 5 factorial into 2 factorial. So writing the question in proper way, then you get an idea. What is the number of persons? How many are there? If, the condition is so that the condition is given. So think and write. So number of persons here 7 members. The question is 7 members and the condition is given. Two particular guests wish to sit on either side of the host. So that is treat the two particular persons along with the host as to 1 unit. That is why then you have total 2 persons means remaining how many? 5 guests will be there. So 5 guests and 1 unit of 2 particular guests. Then it is becomes to arranged in the circular way means 5 factorial ways. And the two particular persons can be arranged either side of the host means this can be done in 2 factorial ways. Therefore, total number of ways is 5 factorial into 2 factorial. This is the question number 6. Then go to the 7th. Find the number of ways of arranging 4 boys and 3 girls around a circle so that all the girls sit together. So 4 boys and 3 girls are there. So then condition so that all the girls has sit together. So you can occupy anywhere the 3 girls has to 4 boys. The 4 boys is there. 1, boy 2. Suppose B3 and B4 like this is there. So the 3 girls can be arranged either this place or this place or like that. All the girls sit together only. So that is why this always sit together means that method is to take a 1 unit. So treat all the girls as 1 unit. Then how many are there? Then we have 4 boys plus this has to 1 unit. 4 boys plus 1 unit. Then totally becomes to 5 things. 5 things can be arranged in a circular means 4 factorial ways. Then the 3 girls cannot be in the same mode. That is 3 girls can be among themselves can be done in here always 3 factorial. Therefore 4 factorial to 3 factorial is total arrangements to be in the circular mode. So always treat the girls as sit together means make a bundle. So they total we have 4 boys and 1 unit of girls. So total things are 5. 5 can be arranged in a circular means n minus 1 factorial, that is 5 minus 1 factorial, 4 factorial ways we can get. Now the 3 girls can be arranged among either this and this and this any way in change of internal arrangement is 3 girls can be done in 3 factorial ways. Therefore, the total number of ways of arrangements are 4 factorial into 3 factorial. That is total value 24 into 6. That is 144 ways you can get. That is the question number similar concept like in the linear permutation. Then go to the next 8th one. Find the number of ways of arranging 7 gents and 4 ladies. 7 gents are given and 4 ladies around a circular table if no 2 ladies wish to sit together. So 2 ladies in previous come together means take it as a bundle, that is unit. If it is no 2 girls sit together means you have to arrange in between the places of voice. So that is the way of writing. So first the question is given, no two ladies. No two ladies means wish to sit together means you have to arrange by first only by taking 7 gents. So 7 gents can be in the arranged in the circular way. That is nothing but 7 minus 1 factorial. Then you get 6 factorial ways. Then 6 factorial ways. So how many gaps you can get? 1, 2, 3, 4, 5, 6, 7. 7 gaps in 1, 2, 3, 4, 5, 6, 7. There is 7 persons there, you can get 7 in ways. If 2 persons are there, 2 gaps will be. 3 persons means 3 gaps will be. 7 persons means 7 gaps will be defined. So then we can find how many gaps in between the 7 gents means. No two ladies wish to sit together means you have to arrange in between the gents. So you in between the gents places only. So first arrangement of gents is in form of 6 factorial is over. Then we can find 7 gaps. In these 7 gaps, by arranging the 4 ladies, 7 gaps we can find. In these 7 gaps, arranging only 4 ladies are there. So 4 ladies can be arranged in these 7 gaps is 7p4 ways. Therefore, total arrangements are 6 factorial into 7p4 ways. 6 factorial is 720 and 7p4 is 7 into 6 into 5 into 4. So total answer is 6,04,800. This is the way of two ladies wish to sit together. Always come together means take a 1 unit. No two means you take a gap method. That is the shortcut. So first circular means n minus 1 factorial. So that is why here 7 gents, 4 ladies. So that is why first arrange the 7 gents. Ladies keep aside. So the arrangements by following gents is 6 factorial. Then we can find 7 persons means 7 gaps we can find. In these 7 gaps, by arrangement of 4 girls can be done in 7p4 ways. So total arrangements means first option work 1 and work 2, that is 6 factorial into 7p4 ways. This is the question number 8. Question number 9 is find the number of different ways of preparing a garland using 7 distinct red roses and 4 distinct yellow roses. 7 red roses and 4 yellow roses, such that no two yellow roses come together. No two, that is the permutation under condition is restriction is given, that is no two means you have to follow the gap method. If it is come together means make a bundle. That is the way. So here also hanging type, that means preparing a garland. Garland means flowers, making a flowers, roses or flowers anyway. So garden like this. So preparing a garland by using 7 distinct red roses, 4 distinct yellow roses, such that no two yellow roses are come together. So no two yellow roses means you don't keep aside by 4 yellow roses. So first arrange by 7 roses. 7 red roses in the garland form. If it is garland, circular means n minus 1. Hanging type means you take half into n minus 1 factorial. Anti-clockwise and clockwise direction same na, so then the total arrangement will be half making into n minus 1 factorial by 2. That is why half into n minus 1 factorial. Here n equal to number of red roses are 7. That is half into 6 factorial ways. This is the way of half into 6 factorial ways to first red roses in a garland form. Then we can find 7 red roses means we can find obviously 7 gaps. In previous problem also same. 7 persons are there, 7 gents are. So how many numbers gaps we can find means in circular means don't take the values, only as n means in fine gaps will be we can find. So in 7 gaps we can arrange by 4 yellow roses, 7 gaps. In the between we can got the 7 gaps with 4 yellow roses. So this can be done in here also 7p4. Therefore total arrangements are half into 6 factorial into 7p4 ways. By this is the number of circular permutations by using the no two yellow roses are come together. First treat the no two yellow roses come together means first arrange the 7 red roses in a garland form, that is half into n minus 1 factorial, that is half into 6 factorial ways you can get. Now the seven flowers, 7 red roses means you can find 7 gaps in between them. So in these 7 gaps we can arrange by 4 yellow roses. That can be done in 7p4 ways. Therefore, total number of circular permutations are half into 6 factorial into 7p4 ways. This is the question number 9. Then go to the question number 10. Find the number of ways of preparing a garland with 3 yellow, 4 pink, and 2 red roses of different sizes such that the 2 red roses come together. Always this only method. Permutations of the under condition restriction type. Come together means you make a bundle. If it is no come together means make a gap method. That's all. So here the question is such that the value as the condition is given that 2 red roses come together. If you arrange anyway, but the 2 red roses will be always come together. So that means you take this as to 1 unit. 1 unit means we have totally 3 yellow, 4 pink and 1 unit of red roses. Totally how many? 3 plus 4, 7 plus 1, 8. 8 things, 8 objects are we got. 8 objects can be in the form of garland form. They can be in the form of not a circular, that is garland form. Garland form formula means half into n minus 1 factorial, that is half into 8 minus 1 is 7 factorial ways. This is the way of first in 3 yellow, 4 pink and 1 unit of red roses can be arrangements. Now 2 red roses always here take it as a 1 unit. So then we can 2 red roses can be done in 2 factorial ways. Therefore total arrangements are half into 7 factorial into 2 factorial ways. The value becomes to 5040. 2 get cancelled, 7 factorial is 5040. That is the way of come together. No 2 red roses come together means if you take come together, you can make a bundle, then you have the remaining how many are you can count down. In the form of garland form means formulas of into n minus 1 factorial. Then arrangements of internal arrangements of unit of things, unit of objects. There can be 2 or there can be arranged among themselves internally is 2 factorial ways. So that is total arrangements make into work 1 and work 2. That is half into 7 factorial into 2 factorial. That is 5040 ways. This is the question number 10. Then go to the question number 11. A chain of beads is to be prepared using 6 different red colored beads and 3 different blue colored beads. In how many ways can this be done if no 2 blue colored beads come together? So this is the permutations of restriction second type. No 2 blue colored beads come together means take a gap method. So no 2 blue. So how many are given? 6 red roses, red colored beads, 6 red colored beads and 3 blue colored beads. So the arrangements in these two given that, so that you have to arrange no 2 blue colors. So no 2 blue colored means we should not take this one. Then we first arrange the 6 red roses in the chain of beads like hanging type. Hanging type whether it is a chain or chain of beads or garland of flower, the formula is half into n minus 1 factorial. So by arranging the chain of beads, nothing but this has to in the form that is half into 6 minus 1 factorial, that is half into 5 factorial ways you can get. Now we can find 6 red colored beads means n things are given, this number of ways 1, 2, 3, 4, 5, 6 means he get first 1 gap, second gap, third gap, fourth gap, fifth gap, sixth gap. In these 6 gaps we can arrange, keep aside the 3 blue beads can be arranged. So that should be 3 blue colored beads can be arranged in the 6 gaps and 3 blue colored beads. This can be done in 6p3 ways. Therefore, the total arrangements are half into 5 factorial into 6p3 ways. Now simplify half into 5 factorial means 120, 6p3 means 6 into 5 into 4. So total answer is 7200 ways you can. So the question is given, it is particular persons are make a bundle come together means, and no two particular, no two come together means always you take gap method. So first arrange the keep aside part. So that is, if no two blue colored beads given, so keep aside, then go to first arrange with 6 red remaining. That is 6 red colored beads in the form of half into garland form or chain of beads. Formula is half into n minus 1 factorial. That is a half into 5 factorial. Then we have how many gaps we can find means six red colored beans means you have get the six gaps. In these 6 gaps you can arrange by 3 blue colored beans, that can be done in 6p3 ways. Therefore total arrangements are half into 6 factorial in 5 factorial into 6p3 ways. This is the question number 11. So that is question number 11. VSAQs are over. Then go to the SAQs. Only 4 problems are there SAQs. Finish the VSAQ is over. Now go to the short answer type questions. Only 4 SAQs are there. The first question is given that find the number of ways of arranging 8 men and 4 women around a circular table. In how many of them all the women come together? And second one is no two women come together. Same concept, Nana. Permutation under restriction. First method is come together means make a unit. No two come together means you take a gap method. So first here given that the number of ways of arranging 8 men. So that is 8 men are given. 8 men and 4 women are given. So find the number of, first the question is given, find the number of ways of arranging 8 men and 4 women around a circular table. This total person becomes to 12 persons. 12 persons can be done in the circular way, that is in the form of circular mode, that is n minus 1 factorial. If it is 12 persons mean you get 12 minus 1 factorial, that is you can get total arrangements are 11 factorial ways. In this, the first question is given, all the women come together. First question is given that all the women means 8 men are there, 4 women means 4 women come together means always make a bundle. This has to treat as a 1 unit. 1 unit means then we have 8 men plus 1 unit of the 1 unit of women. Then you can get totally 9 objects. These 9 objects can be in the circular way, that is you can get 8 factorial ways. Then the 4 women should not be in the same order. They can be internal arrangement will be happens. So internal arrangement of 4 women always 4 factorial ways. Therefore the total arrangements are 8 factorial into 4 factorial ways. Always same concept, same method of problems are there. If it is come to the means make a bundle, then the remaining persons plus 1 unit total, it can be done in not in a linear form, it can be done in circular way. Circular way means n minus 1 factorial, don't write 9 factorial. If it is a linear, you can write as 9 factorial. It is circular way means you write as 8 factorial. And 4 women should not be in the same order. They can be internal arrangement will be changes. That is 4 women can be done in 4 factorial ways. Therefore, the total number of ways are 8 factorial into 4 factorial. This next go to the no two women come together. No two women come together means always you take a gap method. So no two women, that is why. So 8 men are there and 4 women are there. It is given in the question. First, the arrangement 4 women should not be in the no two women come together means you should take first arrangement of 8 men. So this can be done in how many ways? N minus 1 factorial, that is 8 minus 1 factorial means 7 factorial means. 4 women should not be come together means first arranged by 8 men. 8 men around the circular is 7 factorial ways. Now we can find how many gaps in between 8 means always number of persons are there, you can sit by in ways. Here also 8 men are there means you can get 8 gaps will be found. In these 8 gaps we can follow by 4 women. Why? Because it has taken a bundle. So 8 gaps and 4 women, it can be done in 8p4 ways. Therefore, total answer is 7 factorial into 8p4 arrangements. Total circular permutation arrangements will be come to be 7 factorial into 8p4 ways. We can find these total arrangements. No two women come together means always first arrange with keep aside by 4 women. Then you have 8 men are there. These 8 men can be done in the circular way, that is 8 minus 1 factorial, that is 7 factorial. So in these 7 factorial, 8 men can be seated in between them. How many gaps we can find means totally 8 members are there, you can find as a 8 gaps. In these 8 gaps, we can arrange by 4 women. This can be done in 8p4 ways. Therefore, the number of arrangements in which no two particular women come together is 7 factorial into first work one is 7 factorial into 8p4 ways. This is the first question of SAQs. Then go to the second SAQ. Find the number of ways of arranging 6 boys and 6 girls around a 6 boys and 6 girls. 6 boys and 6 girls. So that is, so in this around a circular table so that all the girls come together, no two girls sit together, boys and girls sit alternatively. In this same method of question in linear permutation, 5.1 exercise will be completed, but they are arrangements in the form of a linear, that is row wise. But here given that circular permutation. So first question is given that all the girls come together. Find the number of ways of arranging 6 boys and 6 girls around a circular table so that is why first you have to take the first girl. That is all the girls come together means always come together means always make a treat a one unit. So how many girls can be come together means this has to be make a bundle or make a unit. So 6 we have 6 boys plus 1 unit of girls. 1 unit of girls means totally the number of objects will be, you can get 7. 7 objects. Then these 7 objects can be done in circular way. It can be done in 7 objects can be done in 7 circular mode. This can be done in 7 minus 1 factorial, that is 6 factorial. 7 objects can be done in 6 factorial ways. Now the 6 girls cannot be in the same order. Their internal arrangements will be changes. So the internal arrangements of by 6 girls can be done in 6 factorial ways. Therefore, the total arrangements are 6 factorial into 6 factorial. That is the 720 into 720. This number 5,19,400 ways will arrangements are there. So for the question, always same concept. Now all the girls are come together means make a bundle of girls. Then you have 6 boys and 1 unit of girls. They can be arranged in circular mode. Total 7 things are there. 7 things can be arranged in a circular way. Circular way means n minus 1 factorial. That is n minus 1 factorial means 7 minus 1 factor. The arrangements will be with boys. Then you can find these 6 girls should not be in the same order. They can be internal arrangements are there. So the 6 girls can be arranged among themselves is 6 factorial ways. So total arrangements are first work 1 and work 2, that is 6 factorial into 6 factorial. This is the question number first bit. And then go to the second bit. No two particular girls sit together. So no two means you have to arrange by gap method. Okay. 6 boys and 6 girls are there. 6 boys and no two girls come together means you first arrange by 6 boys in the circular way. So in the circular way means you can get as 6 boys means 6 minus 1 factorial ways, that is 5 factorial ways. Now we can find 6 boys means you can get how many ways? 1, 2, 3, 4, 5, 6. 6 gaps. 6 boys and 6 girls can be arranged. 6 gaps and 6 girls can be arranged in the circle. In the arrangements are total things are you can get as 6 factorial ways. Therefore, the arrangements are 5 factorial into 6 factorial ways of arrangements by using the no two girls come together. In the third part is given that boys and girls sit alternatively. Boys and girls sit alternatively. Number of boys and number of girls are here same. So that is where the arrangements of no two girls sit together is same as no two boys are sit together. Anyway are same. If it is a linear, then you get two ways. If the row may begin with either boy, that is the first way. If it is linear and the row may begin with either girl, it can be done in two ways. But it is in the circular way means the arrangements of seating arrangements of starting with boys and girls both are same. 1, 2, 3, 4, 5, 6. This is 6. So the arrangement of girls with starting with girls and arrangement of girls boys with same as this one. So that is nothing but and nothing but two boys sit, no two boys sit together also same. So first, that is why first we can arrange 6 girls. 6 girls can be arranged in circular way means around a circular means how many you can get 5 factors. Now we can find 6 gaps again. 1, 2, 3, 4, 5, 6. In these 6 gaps we can arrange by 6 boys. 6 boys they can be arranged in 6 factorial ways. Therefore the arrangements are 5 factorial into 6 factorial ways we can get. Number of persons are same. So it is in the arrangements should be same. If we suppose if it is linear, the row may begin with boys is a one way and row may begin with the girls as a one way. It is a closed figure. So that is why number of arrangements are same as number of boys in the number of boys arrangements and number of girls of arrangements is both are same. Therefore, the boys and girls sit alternatively means same as the arrangement of the number of no two girls sit together or no two boys are sit together. So that is why first arrange with 6 girls around a circle in 5 factorial. Then we can find 6 gaps. So in these 6 gaps we can arrange with boys. Then it is 6 factorial ways. Total answer is 5 factorial into 6 factorial ways. This is the question number 2. Then go to the question number 3. Find the number of ways of seating 5 Indians and 4 Americans and 3 Russians at a round table. So that is 5 Indians, 4 Americans and 3 Russians at the round tables. In this, so that the question all Indians come together. All Indians come together means always take the bundle, that is a treat as a make a unit. So treat 5 Indians as 1 unit. This has to 1 unit. So totally how many? 4 plus 3, 7 plus 1, 8. So 8 objects or 8 things or anyway 8 things can be arranged in a circular. Circular means n minus 1 factorial. This can be done in 7 factorial ways. So now taken as the 5 Indians always in the not in the same order. So that is the internal arrangement. They among themselves can be arrangements can be find, that is in form 5 Indians can be arranged in 5 Indians can be arranged in 5 factorial. Therefore, total answer is 7 factorial into 5 factorial arrangements will be if you can find. So why? Because all the Indians come together means make a bundle of Indians. Total arrangements as to 1 bundle and then you have 4 Americans, 3 Russians and 1 unit of 5 Indians. They can be arranged in a circular way, that is total things are 8. So the 8 things can be done in around the circle is 7 factorial ways. And the 5 Indians should not be in the same order. They will be some internal arrangement will be happen by 5 factorial ways. The total number of ways are 7 factorial into 5 factorial. And then go to the second bit, no two Russians sit together. No two Russians sit together means you have to arrange first arrange by 5 Indians and 4 Americans around the circle. 5 Indians plus 4 Americans. So around the circle, total persons are 9%. 9 can be arranged in a circular ways. The circular way means 9 minus 1 factorial, that is 8 factorial ways. So that is in 9%, how many gaps we can find means 9 things means 9 gaps will be found. In these 9 gaps can be arranged with 3 Russians. 9 gaps with 3 Russians. 9 gaps with 3 persons can be done in 9 P3 ways. Therefore, the arrangements are 8 factorial into 9 P3 ways arrangements we can get. And the next third question is given that persons of same nationality sit together. Persons of same nationality sit together. So same nationality means always you should all Indians as one unit, four Americans as one unit, and the three Russians as one unit. So as one unit means totally how many are there? Totally 3 units will be fine. So 5 Indians as one unit, and 4 Americans as one unit, and 3 Russians as one unit. So these 3 units can be arranged in a round table means you can get 3 things can be arranged in a circular way means 2 factorial. So always they will come together. Same nationality come to sit together means always you should apply anywhere in the same as unity. You can keep any place. You can get as sit come together means you can make a bundle. This can be done in 2 factorial ways. And next way is the 5 Indians among themselves can be permitted. 5 Indians will be permitted in 5 factor internal arrangement, and 4 Americans can be done in 4 factorial ways. And the remaining total answer is 2 factorial into 5 factorial into 3 factorial. That is the way of arrangements in which persons of the same nationality sit together. And the Russians are there. Russians will be there. So Russians, the 5 Indians, 4 Americans, and 3 Russians are there. 3 Russians also it can be write as the 3 next page I will write. Here write also I'm the 3 Russians in 3 factorial. That is why 2 factorial into 5 factorial into 4 factorial into here 4 factorial into 3 factorial ways. This is the way of third question. Now go to last one. Find the number of ways of arranging 6 red roses and 3 yellow roses of different sizes into a garland. In how many of them all the yellow roses are together? No 2 yellow roses are together. So totally 6 red roses, 6 red roses and 3 yellow roses. The first question is arrangements of how many arrangements into a garland form. Totally 9 are there. Into a garland means the formula is garland form means half into n minus 1 factorial. That is half into 8 factorial ways total arrangements by using the garland form. In this all the yellow roses are come together. All the yellow roses means make a bundle always. This has to 1 unit. Then means 6 red plus 1 unit of yellow roses. 1 unit of yellow roses. Totally how many? 7 things. 7 things in the form of garland. Garland means 6 plus 1 7. 7 things are in the garland form means half into 7 minus 1 factorial. That is half into 6 factorial ways. But we taken as 3 yellow roses as 1 unit. So this can be done in 3 yellow roses can be done in always internal arrangements nothing but 3 factorial ways. Therefore, arrangements are half into 6 factorial into 3 factorial ways. This is the first, all the yellow roses come together. Then second question is, no 2 yellow roses are come together. No 2 yellow roses means you have to select by gap method. First arrange the, no 2 yellow means first arrange the 6 roses into the garland form. That is half into 6 red roses mean into a garland form. Garland form nothing but half into 6 minus 1 factorial, that is half into 5 factorial ways. Then we can find 6 red roses in gap. Gap method means you can find how many gaps? 6 gaps. In 6 gaps you can find, in these 6 gaps you can arrange by 3 yellow roses. Then it can be done in 6p3 ways. Therefore the total arrangements are half into 5 factorial into 6p3 ways. This is the way of question number 4. And then this exercise over today. Then tomorrow I will go to the combinations. Permutation part is over. Linear permutations is over and circular permutations is over. Once again practice all those as the notes is given in the left side. You practice again this. Okay. Thank you, Nana.